Hi, everybody. In order to understand the unique value of the Web3 smart contracts and blockchain industry, I think it's important for us to really deeply look at exactly what it is that this infrastructure and this industry does 10 or 100 times better than anything else currently in existence. I view this on two key dimensions. The first dimension is the distinction between a cryptographic guarantee and the paper guarantee. Paper guarantees are what we've all become used to in our interaction with existing systems. Even if those existing systems are Web 2.0 internet systems, they still provide what I call paper guarantees. A paper guarantee is when you have a legal document that guarantees you certain contractual outcomes. Whether that legal document is from a bank, an insurance company, a peer-to-peer web platform, or any number of other systems. At the end of the day, you have a piece of paper that is only backed by the probabilistic guarantees of a legal system enforcing or maybe not enforcing what that piece of paper says. And this is the way the world has worked for thousands of years up until the emergence of Bitcoin and decentralized infrastructure. With the emergence of Bitcoin and decentralized infrastructure, for the first time in history, you could be provided something called a cryptographic guarantee as far as agreement was concerned. With Bitcoin being the first example of you owning a Bitcoin being the cryptographic guarantee that Bitcoin provided, and then there being a consistent expansion of what cryptographic guarantees can provide into additional tokens and state changes through Ethereum, now onto NFTs and DeFi and decentralized insurance. So the first spectrum is the paper guarantee to cryptographic guarantee spectrum, where on one end of the spectrum, you have a legally guaranteed agreement, which means that depending on your legal system, depending on what courts or arbitrators or auditors or any number of other people-driven enterprises decide, and those decisions are probabilistic because they could be decided in one direction or another, or there could be no decision at all because maybe the counterparty is too large or too influential in certain geographies. So paper guarantees have all this risk and probabilistic nature to them. And cryptographic guarantees, which rely on encryption and private keys, have a deterministic level of guarantees. So it's 100% guaranteed that if you correctly sign something with your Bitcoin private key, you will be able to move that Bitcoin. It's 100% guaranteed that a smart contract that's written a certain way will execute that way every single time. And this difference between probabilistic guarantees and deterministic guarantees is really the more detailed way to look at a paper versus a cryptographic guarantee. So that's the first spectrum. The second spectrum is the difference between definitive truth and not having any shared truth whatsoever. Not having any shared truth is in many cases exemplified by fake news or scams, and definitive truth is exemplified by people pre-agreeing on a set of conditions under which they will resolve their agreement. Examples of things on this spectrum are the differences between news that's considered fake news, where nobody can agree what the truth is, or derivatives agreements that are very, very detailed in what needs to happen for that derivative to settle correctly. So there are legal agreements where the definition of truth and the definition of what needs to happen for them to be settled is very, very detailed because the value in those specific agreements are in the billions, tens of billions in some cases. And then there are institutions and applications and systems that have no idea of shared truth. It's just whatever people say is what people might assume is the truth without any proof whatsoever. And then on the farthest end of this spectrum are outright scams where people told you something was the truth, but it wasn't the truth. And this is where a lot of solvency issues come from, where different organizations are no longer solvent because they simply lied about what the truth was. So on these two dimensions of definitive truth to no shared truth and paper guarantees to cryptographic guarantees, I think we can really deeply examine what it is that our industry does uniquely well, what it's doing uniquely well now, and where it will be able to take society over time, which I think is a very important point. At the end of the day, if you look at how many systems work today, they are in the left portion of the graph where you essentially have paper guarantees, right? You have guarantees about a document. That document can be memorialized in a web application, such as in the case of Wirecard, or it can be a legal document, such as in the case of Enron or Lehman Brothers, or it can be a collection of legal documents and digital documents, such as in the Bernard Madoff, scandal and outright scam. But at the end of the day, these are paper guarantees. You have a paper document that memorializes your relationship, and you hope that that paper document has a solvent entity behind it and a legal system that can enforce your rights in regards to that legal document. That's fundamentally how the world has worked up until now. In the left portion of the graph, that's what you'll see. If you take a look at the left portion of the graph in this vertical dimension of definitive truth to no shared truth, you can have agreements that have extremely high definitive truth, such as derivatives agreements and agreements about how something were to be audited, or insurance agreements. But if you don't have a system that enforces those agreements, you can define them all day long, but they can then fail, right? Because the paper guarantees are probabilistic. The legal system or the arbitrator or whatever system of contracts you use, if it's probabilistic, you can define it perfectly, but the system might fail, right? You still have people trying to get their Lehman Brothers derivatives properly settled. Enron was a huge failure, despite the fact that definitive truth took place and people defined what they were auditing and how they were looking at the organization. You fundamentally had a failure because the system of paper guarantees failed, right? So really, for a high quality agreement and reliable agreement, you need to have both definitive truth and the system of contracts that guarantees the outcome of that defined truth, right? So that's what the upper left quadrant teaches us in this graph, in these two dimensions, is that even if you define agreements, they can still fail if you use a probabilistic system of agreements that only provide paper guarantees. On the lower part of the paper guarantee spectrum is where you have some of the scarier stuff. That's where you have fake news. That's where you have outright scams like Wirecard. That's where you have certain applications like Robinhood that might say that they operate a certain way until they're forced to prove it, and then they operate a different way, leaving many of their users to be insolvent. That's where you have many of the outright scams in history, such as Bernard Madoff and various other Ponzi schemes. You have people that fundamentally renege on their guarantees to their users, and neither the paper guarantees of whatever legal system are able to support the users and able to resolve the issues correctly, and there is no real sense of shared truth to begin with. So the definition of the agreement from the very beginning was vague. And this is the agreement that many people have with a multitude of different applications they use today, whether those are media, social media, payment systems, trading systems, asset managers like Bernard Madoff. This is really the vagueness of these agreements that, in addition to not being correctly or clearly defined, they are still in a probabilistic system that can allow them to fail because they're fundamentally a paper agreement. They're a paper guarantee. So this is the left side of the spectrum. On the right side of the spectrum, going towards cryptographic guarantees, you already have a number of systems that use cryptographic guarantees to provide you with a sense of reliability, namely messaging applications. So many of the messaging applications people use, whether those are WhatsApp or Telegram or Signal or any number of messaging alternatives, they are now almost all using end-to-end encryption. And end-to-end encryption doesn't have any conception of a shared truth. It doesn't say that something is right and something is wrong, but it does provide you cryptographic guarantees. It does give you a sense that your communications will remain private because they are encrypted in a specific end-to-end encryption process. And because of the loss of faith in unencrypted communication systems and channels, now many applications in the communications and messaging world use end-to-end encryption as a key selling point. They didn't before. Decades ago, they didn't. They just said, we're a messaging application and we're very fast and you can download the application. But then the lack of cryptographic guarantees and the failures of messaging applications that didn't have end-to-end encryption became so apparent that users demanded a new minimum. They demanded a new minimum standard for how communications happens, namely end-to-end encryption. And this is now a question that the vast majority of users of messaging applications ask. They ask, how is the messaging encrypted at rest? How is it encrypted in transit? How is the information I'm putting in this application kept private? And the appropriate correct answer is end-to-end encryption, which is a cryptographic guarantee. So you actually already do have cryptographic guarantees permeating many parts of your life, and they have given you the kind of sense of comfort and psychological safety to use an application. So this dynamic already happens on the right side of the spectrum. What we're talking about in the blockchain industry and in the smart contract industry and in the DeFi industry and in the Web3 industry, whatever we want to call this industry that's quickly evolving and clearly starting to impact people's lives rapidly, is applying this same type of cryptographic guarantee dynamic to other very important parts of daily life, various key transactions, how society works, and various other key problems that on a case-by-case basis matter deeply to certain industries and certain categories of users, but might not matter to other categories of users, right? So does everybody get excited about derivatives contracts that are cryptographically guaranteed? Maybe not, because they don't use cryptographically guaranteed derivatives contracts or derivatives contracts at all. But I can tell you that the people that do make derivatives contracts, or the people that do care about insurance, or the people that do care about whether their concert tickets are real or fake, do really care when the reliable systems that guarantee the correct resolution of a derivative, or whether their concert ticket to their favorite show is a real or a fake. All of those specific groups do care. So what you really see with the implementation of cryptographic guarantees in the Web3 world is a very specific set of applications. And some of these applications are called DeFi, some of them are called NFTs, some of them are called tokenized ownership, but these are the very early examples of cryptographic guarantees making their way into people's and industries' daily operations, but in specific industries and specific verticals. But let's look at how this evolves generally. So let's look at the general categories of applications through which cryptographic guarantees are going to permeate specific industries and specific categories of human activity. The first category is something we call trust minimized applications. So trust minimized applications are actually a combination of cryptographically guaranteed systems, definitive truth systems, and centralized systems. There are already a multitude of different users of Chainlink networks and users of blockchains that combine those systems with a centralized server. So these are often cryptocurrency exchanges, various other cryptocurrency CeFi applications. They create output in cryptocurrency. And some of them have begun to adopt decentralized Oracle networks as a data source, which means that the inputs into those systems are also now cryptographically guaranteed. This is a spectrum, and there are some trust minimized applications that give you access to cryptocurrency that don't share with you how much cryptocurrency they hold. They don't tell you how much is in a specific address for your account, and they kind of just hold it in ways that doesn't provide you a lot of cryptographic guarantees or definitive truth. Then there are others which provide you very clear guarantees about exactly what you own. Your private key might even control certain aspects of it. And some of them are now adopting decentralized Oracle networks as a way to get data in. So the new architecture that we're seeing is a trust minimized application, has a centralized core, it has blockchain-based outputs, and it has blockchain-based and Oracle network-based inputs. So you can't really deviate very much when your central core has committed to something, and the inputs are transparent and the outputs are transparent. So the first stop is really trust minimized applications. As we go up the what we call cryptographic truth curve, we start to see more and more decentralization, more and more cryptographic guarantees, until we eventually arrive at something called hybrid smart contracts. Hybrid smart contracts are things like DeFi, decentralized insurance, basically digital agreements that have been memorialized in a blockchain, right? So you have the actual conditions of the agreement in a blockchain. That creates the on-chain portion of the agreement. And then you have decentralized Oracle networks such as Chainlink, which provide the data and the inputs and the outputs and all the conditions under which the agreement is resolved. And that combination creates hybrid smart contracts, which are fully decentralized. So this means that every condition of the agreement is defined up front. achieving a very high level of definitive truth, putting that definition on chain for everybody to verify. The Oracle networks and all the systems that are proving things to the agreement and controlling the agreement and allowing the agreement to do things are also very clearly predefined. Under what conditions does the crop insurance and a decentralized insurance smart contract resolve is very clearly defined. There are these 5 data sources from 5 different weather data systems that if they say there was no rain, then the decentralized insurance policies paid out automatically without any intervention, without any ability to even stop or reassess or minimize the payout from the policy, because we've predefined what definitive truth is. We've said there's 5 data sources over there, and those data sources are going to prove whether it rained in a specific geolocation. And we as the contract participants are comfortable with that very detailed definition of truthful of a definitive truth outcome. And we're going to write that in to a smart contract and to a set of Oracle networks, which are going to cryptographically guarantee that outcome. And this solves a massive array of problems where you no longer have to rely on somebody changing what the truth is after something happens. And that is enforced and guaranteed by these cryptographically guaranteed systems. So basically, just like the messaging application you use can't be compromised because it uses end-to-end encryption, under the same set of encryption and cryptographic guarantees, which are deterministic and are outside the scope of failure, basically, you can now have those same guarantees about the solvency of your bank, the payout from your insurance company, whether the concert ticket you purchased is real or fake, whether or not various guarantees from various institutions are going to be guaranteed, whether or not you're going to be able to use a social media system in a certain way, whether or not you're going to be able to use a trading system in a certain way. In the past, on the left side of the spectrum, none of that could be guaranteed because it was all a probabilistic paper-based system where people controlled the servers, people controlled the systems that allowed you to trade, allowed you to use a payment system, allowed you to execute a derivative. Your asset manager just held assets and you had no clue what was going on with them. On the right side of the spectrum, after you go into the world of cryptographic guarantees, you initially see that there are impartial private key signing systems that allow the signing of messages and the communication of data in an end-to-end encrypted way. And then you really have to ask yourself, well, how can I get the same guarantees, the same reliability, the same infallibility for all the rest of my digital life, for all the rest of my interaction, both with institutions and with peers through web platforms? And that's what Web3 provides. It provides the ability to get a cryptographic guarantee, and through Oracle networks, allows you to create definitive truth, allows you to predefine under what conditions you would like money in a certain bank. And the second that those preconditions are not met, a second that bank falls below a certain level of solvency, your money can automatically be removed and automatically put into a more solvent bank, which is exactly how DeFi works, right? DeFi is actually the best current example of this, where if you look at how current banking systems work, they work under a set of paper guarantees where nobody really understands what the solvency of many banks is. Audits happen on an annual basis or a biannual basis, and even those are known to be inaccurate in many cases, which is why there are constant solvency issues, risk management problems, and why using bank systems takes days to weeks. On the other hand, when you have cryptographically guaranteed systems, such as DeFi, you can know everything that's happening with the DeFi application on a minute-by-minute basis. The analogy would be if you knew every single thing happening at Facebook day to day, minute to minute, every single decision that was made, every internal process that was executed, every single thing that their pieces of code did, and every decision they made. Or if you knew that about how your bank worked, or if you knew that about how your insurance company worked. And everybody could monitor exactly what the insurance company was doing minute by minute with every policy that it wrote, with every decision that it made, every policy it didn't resolve. Likewise for social media platforms, banks, and everything else. This is the big difference. And the difference is one that I think people need to really wonder about and ask themselves, why would somebody make a less reliable agreement if they could make a more reliable one? That is the fundamental truth of this industry. is that regardless of what it's used for today, whether it's for tokens or NFTs or whatever collection of activities, at the end of the day, as Web3 approaches the speed, the efficiency, the low cost of web systems, it has a guarantee that no Web 2.0 system can ever have, which is the trust minimization cryptographic guarantee. It can guarantee you that your assets are safe, that your assets are under your control, that you know what is happening with your assets on a second-by-second basis. You don't need to wait for an annual audit that might still be false, just like in the case of Enron. And these are the unique properties of our industry, and this is the unique direction that it's taking the world. It's taking it into a direction where the false paper guarantees of the past simply can't happen. And I think the thing that everyone needs to ask themselves is whether this is a world that they find exciting. I think it's an extremely exciting world, because what it means is that in a developed market, you will no longer have these kind of false outcomes. You basically won't have the ability for outright scams like Bernie Madoff. You won't have the ability for people to overextend themselves like Lehman Brothers. Things like Enron and Wirecard that were highly audited institutions simply won't be able to happen, because everybody will be able to audit the data on a real-time basis. And even various applications that promise you one thing and do a different thing, like Robinhood, simply won't be able to do that, because the systems that they're built on will force the application to work in the way that was promised to you. And so this is the big shift from Web 2.0 to Web 3.0 that I think all of us should be extremely excited about, and that our industry is working on. With this result, what this will result in eventually is a globally interconnected system of contracts that can be used by everybody, regardless of country, wealth, or any other criteria. So you will now have a system of contracts that is used by everybody globally, whether you're in the poorest country or the richest country. And those contracts will be enforced equally, whether you're a poor single farmer in some part of the world where you just want to sell your grain internationally, or whether you're a large multinational grain purchaser. You will have a single system of contracts. You will not have any advantage in that system of contracts, regardless of who you are, whether you're big or small, because that system of contracts will be cryptographically guaranteed. Just like nobody using an end-to-end messaging application has any advantage over anybody else, because the system is completely impartial and enforced through encryption. This is where the entire world will go, and this is where our industry is accelerating it going. And if this is something that you think is worthwhile, a global system of contracts that creates transparency for developed markets and brings emerging markets from having no system of contracts for bank accounts or insurance or other things into a world where people can reliably utilize contracts to pursue their economic destiny, whether domestically or across borders. That is, in my opinion, a world worth working for. And that's what we're doing in this industry. And that's what Web3, blockchains, smart contracts are about. What they're doing now, tokenization, NFTs, DeFi, is just the very, very beginning. It is the absolute early days of the internet, where you had unencrypted email and e-commerce was just an early idea. That's where our industry is. And just like the internet took people from having no information, having people that didn't have access to books are able now to get information from a phone that I use. They're able to get Wikipedia and all the best world's information because the internet gave them that. And just like telecoms allowed people that never had a phone to have a cell phone and be able to call across continents, this is the same level of magnitude change that smart contracts, blockchains, and Web3 provides. It will allow people that have no system of contracts, no way to save money, no way to get insurance to combat climate change as a farmer, no way to counteract various adversarial economic dynamics. And it will give them the same system of contracts that is so superior to what the developed world uses, that both the developed world and the emerging markets will all be on one global system of contracts, all playing by one set of rules that are cryptographically guaranteed through encryption and that have a single definition of truth that everybody agrees on is the definition of truth that they want to use to resolve their agreements. That is the amazing change in the world that our industry is creating. I think the adoption of this change in the world is at a unique moment in history as well. In the past, there have been various categories of failures for what we call paper guarantees and weak paper guarantee systems. I think we are at a unique point in history where some of the decisions to engage in more paper guarantees, such as in the 1970s and then in 2008 with the global credit crisis, have not made the significant enough impression of the dangers of engaging in paper guarantees. And this set of graphics here, where people essentially use paper guarantees, use them to the point where they overuse them, pause using them for maybe 5 years, maybe a decade, and then take the mantle up again and begin to use those paper guarantees to extreme excess, is actually the history of paper guarantees. So if you look at the history of paper guarantees over thousands of years, this is exactly the pattern. The pattern is, hey, we made a new paper guarantee. We should really be careful with it. It's really exciting. People massively overuse it. They massively overprint money. They massively over create certain contracts. Then there's some kind of failure, and that is essentially a warning signal to people. And it says, hey, look, this has consequences. Using paper guarantees in this form has serious consequences that we need to be aware of. And then throughout history, consistently, we seem to just say, it'll be fine. It'll be okay. Let's do it again. Except we learned so much the first time. Let's do it 10 times more this time because, last time wasn't enough for us. This is actually what's happening now in various categories of private debt, public debt, and all kinds of other guarantees. So I think we're at a unique inflection point where people in various economies all over the world and in various categories of paper guarantees have simply decided to overstretch what a paper guarantee is able to do. And this has now led to the very, very early signs of the consequences of doing this. And those consequences are being seen in various specific contractual arrangements in things like real estate with Evergrande and other categories of agreements such as derivatives. And there are these extreme kind of jumps in outcomes. But the most general jump in outcomes has really been inflation. This is really what the average person is going to be impacted by most, is the impact of inflation, as well as the various other specific contractual outcomes in specific industries for specific entities. But if we were to just think about inflation, even just inflation as a paper guarantee, basically reneging on its promises, basically going in a direction that people don't expect it to go. This presents, I think, a unique opportunity for the world to switch to a cryptographically guaranteed way of operating. So I personally believe that for thousands of years before this point, there was no alternative to how society could work, how peer-to-peer agreements could work, how institutions could agree with peers and with each other. And for the first time in history, we have a way to create cryptographically guaranteed systems that enforce certain minimums, enforce certain relationships between peers, between institutions, between peers and institutions, whether that's as something as simple as a concert ticket, or whether that's something as important as a country's, 100 billion asset fund that uses derivatives to hedge against various negative outcomes and save the value of the entire country's pension system. Whatever degree of importance the cryptographically guaranteed agreement takes, we now do have a way to create cryptographically guaranteed agreements. And we have a more and more advanced way to do that. Those agreements are the better alternative that we now have as society, as a set of internationally interconnected, globalized systems and countries and institutions. And I think that the oncoming inadequacies of paper guarantees are going to massively show. They're going to shine a very clear light on the right way to do agreements being cryptographically guaranteed agreements, just like the failure of messaging applications that had no encryption and no end-to-end encryption guarantees eventually was a demand everybody had, because there was a set of failures that showed people how weak the guarantees of a system without those cryptographic additions was. So this is where I think we're going, and I think we're at a unique inflection point in history, and I think our industry is the industry that is able to take the rest of the world into a cryptographically guaranteed and cryptographically truth-based set of contracts, and really society, and a set of societies that interact with each other in cryptographically guaranteed, cryptographically truth-based ways. This is why our goal in working on the Chainlink network is to build a world powered by truth. I personally feel, and a lot of people working on Chainlink feel, that we are now at a unique point in history where you can build a world powered by truth, and not a world powered by any one specific person's truth or any one specific group's truth, but a world powered by a pre-agreed upon shared definition of truth that is then enforced and made immutable and made true because it is something that is cryptographically guaranteed. So it's cryptographically guaranteed in a system that can't be manipulated by any of its users. And it has a new dimension of definitive truth enabled by Oracle networks so that people can define what they think is a true outcome. And that can be proven to them in a way that is infallible. This is the unique place where I feel we are in history. And this is why we, in our work on Chainlink, see ourselves as building a world powered by truth. If we consider how this has been evolving, there will be a very clear picture of the in the evolution of what a smart contract is. So once again, hybrid smart contracts are the pinnacle of cryptographically guaranteed and cryptographically truth-based systems. But that is where we're going. That's the journey that the industry and the world is on. Right now, it might be useful for us to look at how that has historically evolved and also where that's going. So historically, you initially had really only one smart contract. That smart contract was about tokenization. It was about keeping a ledger of assets and who owned those assets. And that was the only thing that there was, and that was a single smart contract. Then the definition of a smart contract expanded to include multiple different contracts interacting with each other. This is when more advanced smart contract platforms like Ethereum and others came into existence. Bitcoin was the initial originator of that one smart contract. And even on Bitcoin, you did have two smart contracts or more where you had the ability to do something like multi-signature. So you pretty quickly had an evolution from just one smart contract about keeping track of assets to multiple smart contracts interacting with each other for distinct purposes. And this isn't surprising because if you look at how web applications are built and how even the earliest web applications were built, you saw the same dynamic. You saw more and more distinct pieces of code acting as distinct services or having distinct separation of concern roles, whether it was a database or whether it was a piece of code or whatever it was. You kind of saw a meshing and an integration of many different systems into more and more advanced web applications from the earliest days of the internet. And so not surprisingly, this has been the evolution of smart contracts, where while they were initially one contract, they then evolved to be that contract plus a multi-sig plus a voting contract plus a few other contracts on one specific chain. Recently, you've had a massive expansion in what defined a smart contract by including the world's off-chain data. This is the innovation that decentralized Oracle networks are responsible for. This is the innovation that we have massively moved forward in our work on the Chainlink network. And really the Chainlink network launched the first decentralized Oracle networks and really pioneered the ability to provide off-chain data in a reliable, consensus-driven, deterministic manner. The key point here is that you have a larger definition of what a smart contract is. So now a smart contract is these two contracts or three contracts on a single chain, but they're using an off-chain system that is also a trust minimized consensus-based system that provides deterministic guarantees about the accuracy of, in this case, off-chain systems and off-chain data. This was previously impossible because blockchains and smart contracts were not able to verify whether something was true, and they weren't even able to access external information for security reasons. So the ability to provide external data into the smart contract systems and blockchains of the world basically gave rise to something called DeFi. And this is the first category of what decentralized Oracle networks and Chainlink networks were used for and are being used for today is the provision of highly validated data, which basically means that the same way that consensus and multiple independent nodes generate a sense of cryptographic guarantees and encryption-based guarantees for blocks and transactions of blocks in a blockchain, you now have, there is now, and has been for some years now, a way to generate that same level of guarantees about external data. So what Chainlink networks and decentralized Oracle networks fundamentally do in the highly validated data category is they allow people to predefine that these 10 data sources will prove what the truth is. They will cryptographically prove what has happened in each individual data source's case. And then there will be a consensus mechanism and a decentralized computation mechanism, which is the Chainlink network, which are the Chainlink networks, that come to consensus about all of that. The first place where this has been massively used is price data and market data, which is not surprisingly what powers DeFi. So decentralized finance is really the first evolution of blockchains and smart contracts going beyond tokenization. Tokenization was the first big boom in blockchains and smart contracts, where there was a massive influx of various tokens being created, traded, and owned for various reasons. But decentralized financial applications, while they can hold some of those tokens, they are actually about creating an agreement. They are about creating a financial product that is fundamentally an agreement. And those financial products are composed of two equally important parts. One of them is the on-chain code, the on-chain contract, which is the cryptographically guaranteed agreement itself, where the conditions of the agreement are defined and where the state changes of the agreement occur. The other half of the DeFi agreement, the hybrid smart contract agreement, which all of DeFi is a hybrid smart contract, you have the Oracle network. The Oracle network provides the massive insight and connection and cryptographically guaranteed truth of what happened with something as simple as the price of a specific asset. And you do need the price of an asset in order to make the vast majority of financial services and the vast majority of financial products, which is why the vast majority of DeFi is indeed a hybrid smart contract powered by an Oracle system. This is the initial area that we focused on and is the initial area where we have now been able to achieve both a huge amount of data points on chain, a huge amount of distinct Oracle networks providing data, and massive, massive adoption that actually allows the DeFi industry to scale. Over this past year, we have been able to solve a massive scalability challenge in the Chainlink network's ability to generate many, many different Oracle networks. And we, in this case, really means our larger community, us as Chainlink Labs, and a lot of different great people that we're extremely grateful to for the collaboration and thoughtfulness that has gone into generating the systems that have allowed the Chainlink network to go from a few Oracle networks to over 700 Oracle networks. The Chainlink network is really unique in that while many blockchain-based and decentralized consensus systems are focused on generating many, many different shards, many different side chains, many different copies of themselves in order to achieve scalability. Over this past year, the Chainlink network has been able to achieve this scalability by creating over 700 distinct Oracle networks that provide over 700 distinct services. So this, I think, is a very large milestone in the scalability of not only Oracle networks, but in the scalability of decentralized computing systems generally. In addition to providing the scalability and the various many different ecosystem companies and Chainlink Labs working together to arrive at this massive, massive growth, there has also been a huge uptake in the data sources that are willing and providing data to the Chainlink network. This expansion also underscores a huge collective effort by the community and various key players in the Chainlink ecosystem, as well as the data providers themselves, realizing that the smart contract economy that has been enabled by putting more data on chain has now grown to the point where some of the world's top data providers see value and see the need to participate in providing data to the large and growing market. So beyond the fact that the Chainlink network has launched massive amounts of decentralized Oracle networks to meet the needs of top DeFi, decentralized insurance, and various other smart contract products. There has also been a massive influx of high quality data providers that can enable the new use cases that go beyond traditional DeFi and traditional NFTs and traditional blockchain gaming. This is the other thing that's massively exciting from the point of view of highly validated data, where not only do you have aggregations of data in Oracle networks powering tens of billions of dollars in DeFi smart contract value, but you have top tier data providers seeing the ability to provide cryptographically guaranteed data as a new market and a new advantage for them, which means that the size of the hybrid smart contract economy has reached a critical mass, a critical threshold where high quality data providers provide the data. Systems such as Chainlink provide the cryptographically guaranteed capabilities to send that data into smart contracts. When combined with the smart contract itself, enables entirely new capabilities and entirely new categories of smart contracts, such as decentralized insurance. Specifically decentralized crop insurance, which I'm personally very excited about because it'll allow massive amounts of emerging market farmers to counteract the effects of global climate change by engaging in cryptographically guaranteed agreements. And those cryptographically guaranteed agreements will give them superior guarantees to the guarantees that farmers get in even developed markets. And that will be a very clear sign of the mimicking of the massive impact of cryptographically guaranteed agreements, because those farmers and those people in emerging markets went from having no phones to having cellular phones. And they went from having no libraries and no books to having a device through the internet that provides them access to the best data, the same data that I can watch on YouTube, the same data that I can read on Wikipedia. And now we as an industry are successfully utilizing the massive growth of the blockchain industry and the community and the Chainlink network and all of these amazing connections between data providers, application developers like Arbol and others, now gives rise to the truly impactful version of cryptographically guaranteed agreements that, in my opinion, can use tokens and can eventually be tokenized, but make an entirely distinct value proposition that never existed before to parts of the world that would have to wait decades upon decades for anything approaching this. And now they don't. Now they can have cryptographically guaranteed bank accounts, cryptographically guaranteed insurance, cryptographically guaranteed systems of trade that don't extract value from them, but allow them to fairly trade in the global marketplace. And all of this fundamentally creates a fair, unbiased world where everybody can pursue their economic destiny on the same level playing field. And that is the amazing thing that our industry is doing. We are all working on in the Chainlink ecosystem and what we're all extremely excited about. If you look at the amount of data that has been put on chain, this is really, I think, one of the large precursors of what is coming. Because every single time that we have put larger and larger amounts of data, there has been a jump in the amount of smart contracts being built, both in the variety of contracts and in the depth and quality of contracts. We have now, with the scalability released this year in the form of OCR, not only been able to launch massive amounts of Oracle networks, right? And when I say we, I mean our community, all the node operators, all the data providers, all the amazing people working on making Chainlink a widely used global resource for cryptographic truth. And all of those people together have now been able to not only launch a massive amount of data points onto many different chains, over 10 blockchains, but they have also been able to provide that data in various categories and new categories that were previously inaccessible. And this was actually the exact problem that was initially solved for DeFi by the Chainlink network and by the provision of the initial decentralized Oracle networks that Chainlink initially made available as a system. It was the appearance of any market data at all. And once market data and prices appeared on chain, you then saw decentralized financial products being created out of nothing, well, not out of nothing, but out of the amazing efforts of the DeFi teams. But a lot of those contracts had already been written and a lot of those contracts had already been built. And the problem was the lack of data to trigger those contracts and to make those contracts come to life. So for me, the rate at which data is put on chain and the categories in which data is put on chain is actually very often a precursor to the growth of specific blockchain categories of usage and blockchain industry adoption by industry, by vertical, by contract type. So I'm very, very thrilled that the Chainlink network has achieved this level of scalability, has put over 1 billion data points on chain, and has put those data points on chain, not only in price data, but in various other categories that are now jump-starting entirely new categories of smart contract usage, such as decentralized insurance. Something that I think all of us in the Chainlink ecosystem and everybody in the entire blockchain industry should be proud of. The next category of expansion for smart contracts is actually the hybridization of how a smart contract is built. And you see this more and more, and we see this more and more in the Chainlink ecosystem through the combination of multiple distinct Oracle networks with individual smart contract applications. Right now, there are multiple smart contract applications that are using multiple distinct Oracle networks. So they might be using a few Oracle networks for different data, but they're also using different Oracle networks for something like keepers, and they're using certain cryptographic signing solutions like VRF for random number generation. The two first examples that we have gone into in the category of off-chain computation have been the provision of random numbers and the provision of keepers, which is an automation dev tools capability. Both of those have become massively adopted by a wider and wider array of varied users. In the case of verifiable randomness, what has been seen by us in the Chainlink ecosystem and in terms of the Chainlink network's usage is that there is a multitude of different use cases that essentially want to become provably fair. And they want to become provably fair by guaranteeing their users with a cryptographic guarantee that the randomness used to generate the NFTs, to distribute the tokens, to decide how the game outcome was played, to decide how any number of outcomes were generated in the application are provably fair. And provably fair, once again, means that there's cryptographic guarantees that can prove that something was generated at a certain level of accuracy and at a certain level of reliability and at a certain level of tamper-proofness that was previously not possible. Right now, VRF has served over 2.5 million requests on multiple chains to many of the leading NFT and gaming applications because those applications wanted to consistently prove to their user base that they were provably fair, that they had a cryptographic guarantee that was generating a reliable source of basically trust and guarantees to their users. And you actually see this in many of the users of VRF where they say to their users publicly that this is a provably fair game, it's a provably fair NFT generation event. It's guaranteed by this set of cryptographic guarantees from Chainlink VRF. And that's been quite amazing to see because it basically shows, and in many cases proves, that there is massive demand not only for the consensus around highly validated data, but there is massive demand for the consensus around computations that smart contracts can't do. And the massive adoption of VRF is something that is only accelerating at this point. Because once again, cryptographic guarantees are where the world's going. Many of these games, NFTs, and other categories of VRF users are in a market where they have a highly sensitive group of users, right? Their users are sensitive to cryptographically guaranteed systems. And therefore, they as consumers of cryptographically guaranteed infrastructure want to turn around and show their users that something is cryptographically guaranteed. But once again, I feel that the whole world will move in the direction that cryptographic guarantees are worthwhile. And so we see demand for highly validated data and random number generation, not only by highly reliable smart contracts and fully decentralized applications, but also by trust minimized applications that want to prove to their users that the random number that they're using in their game is computed in a provably fair, cryptographically guaranteed way, because that has been a consistent problem in off-chain gaming systems. And we actually do see multiple people adopting Chainlink decentralized Oracle networks for the purposes of proving to their user base that the data inputs into their settlement process are reliable. So this acceleration doesn't just extend to decentralized applications. It actually extends to all applications that want to provide cryptographic guarantees. All of this is quite clearly shown by the massive uptick in adoption. So the massive uptick in adoption really has 3 to 4 key categories. One key category is the amount of GitHub repos, individual pieces of code, and various smart contracts that are integrating all of the different Chainlink network systems, whether they're for data or whether they're for off-chain compute or whether they're from randomness or whether they're for any number of collections of those services into one application. And even in the last 6 months, there has been a twofold uptick in that. The next metric that we tend to look at is the amount of partners and projects in the ecosystem. Both the rate and the quality of projects that are continuing to adopt Chainlink is just massively growing over time. I think what we've seen is that the amount of partners and projects adopting Chainlink as a way to get their data into blockchains, as users of that data, as blockchain partners is only accelerating, which I think speaks to the massive quality of what the Chainlink network provides. The next metric is some of the community growth. The community growth of the Chainlink community itself, as characterized by our annual conference, the Smart Contract Summit, and as characterized by the amount of developers attending our hackathons, has been on a really upwards trajectory. There has been a huge uptick in the amount of Smart Contract Summit participants and registered attendees. The Chainlink Network's hackathons have now become some of the largest in the blockchain industry, which I think is quite amazing. The key metric that I think is perhaps the most impressive and the most meaningful is the amount of value fundamentally secured by the Chainlink network. The amount of value secured by the Chainlink network has had a more than 10x increase in this previous year, going from approximately 7 billion at the end of last year to over 75 billion at the end of this year. This is because of the quality of the highly validated data provided to power DeFi, which has also grown massively. It is also because of the various new capabilities that the Chainlink network provides, whether that's randomness, whether that's decentralized off-chain compute, and also the various new categories of data. So this growth is actually just a sign of how much the Chainlink network is impacting all of these industries. Because at the end of the day, if you look at the size of DeFi and you look at the size of some of the applications that use us, and you look at the amount of value secured by the Chainlink network, it really makes the Chainlink network probably the second most value securing system in this industry. And that is something that's possible because of all the various services and all the various capabilities that smart contracts need to consume from decentralized Oracle networks. And I think that this dynamic is only going to increase because we not only see existing decentralized services users adopting more and more of Chainlink networks and Chainlink network-based services like data feeds. We see them adopting a greater and greater amount of those categories of services and actually demanding and generating greater quality in those services in terms of data quality, lower latency, and any number of other features that they need to continue to expand their application, right? Because they need to continue to create higher and higher quality markets and more markets. We also see a large influx of users utilizing multiple different Chainlink networks at the same time. So there is actually a large influx in combining the use of a decentralized Oracle network running in the Chainlink format for data, but also using a Chainlink network for keepers, or using Chainlink generated random numbers, or using Chainlink generated other capabilities. And so now what we see is smart contracts that are actually composed of multiple pieces of on-chain code, but also multiple pieces of off-chain decentralized Oracle network code that all interact together. And I think that the Chainlink network and our entire community should be very proud of not only the fact that this much value is secured by the Chainlink network, and not only that the existing categories of data consumption are continuing to grow massively, but I think that all of the effort by us as a community. And what we have done is a large community of data providers and node operators and developers, and also the many users that give feedback and actually contribute to the improvement of various Chainlink networks, have now generated hundreds of systems, over 700 Oracle networks that secure this value successfully in the face of various reliability challenges like congestion, like flash loan attacks, like flash crashes and exchanges, all of which over this past year have left this value unaffected because of the collective collaboration between everybody in our ecosystem, between node operators, data providers, developers, users, and everybody else. And so not only has the Chainlink network generated massively reliable Oracle networks in large numbers, but the Chainlink network has generated that while being able to stand up to various reliability challenges like congestion, like flash loan attacks, like flash crashes on exchanges or certain specific data sources, which in my opinion is something truly to be proud of, because scaling a system is one thing, but scaling a system in a way, in a community-driven way that continually stays secure against various adversarial and reliability events that affect other systems, but leave our systems and our user systems therefore unaffected, is truly amazing. And that's what I think the Chainlink network and the community should be truly proud of. This year, we've seen a number of different decentralized services gain massive adoption, and I think we as a community should be very proud of that. In the future, the massive growth in various decentralized services, coupled with the growth of various smart contracts, and actually the emergence of more and more decentralized services driven by our community and driven by everyone working together to generate high quality data inputs, high quality random number generation, high quality off-chain compute, is something that is going to continue to jumpstart those new smart contract verticals. So not only are the decentralized services created by the Chainlink network and its community critical to making all of these smart contracts happen, but we actually, as a community and as a network, accelerate the creation of all those smart contracts to the benefit of those decentralized services that then get consumed in greater and greater number, right? They get consumed more and more because DeFi grows more, dynamic NFTs grow more, blockchain gaming grows more, centralized insurance grows more. And both the breadth of new services and the continual improvement in quality of existing adopted services is something that I think the Chainlink network and the entire Chainlink community should continue to focus on and grow, which I know that we as a community and we as a network are doing. In the coming year, in order to create these new services and these new categories of activity that will jumpstart entirely new and innovative uses for smart contracts, there are 3 key initiatives that are being planned for the Chainlink network and that are being planned for the coming year. Those key initiatives are the release of CCIP, the release of staking, and the solidification of Chainlink as an abstraction layer for enterprises. CCIP is the application of Chainlink's highly secure consensus mechanism that secures over 75 billion and has done that successfully for multiple years to the problem of cross-chain communications, such that it is not just about moving tokens. It is actually about communications. This is the big distinction of what CCIP does. CCIP will create many distinct bridges, and those many distinct bridges will move tokens between chains and between applications. But in the opinion of many of the people building CCIP, that is a very limited scope. Just implementing the ability to move tokens is really not enough to take our industry into a world of what we call cross-chain smart contracts. This is the 3rd large evolution of how the definition of a smart contract will expand. Where the first evolution, if you'll remember from earlier in the presentation, was going from 1 contract to 2 or more. The second evolution was going from multiple contracts on a single chain to those contracts using trust minimized off-chain systems in the form of Oracle networks to acquire data, to acquire computation, to interface with all of those systems reliably. The third large shift and the third large expansion in how smart contracts are going to be defined is the creation of a cross-chain smart contract composition capability. So that you don't just generate a smart contract or a set of contracts on one chain, and that's your smart contract. You can now generate, or you will be able to generate with the emergence of CCIP in this coming year, a smart contract that is actually multiple contracts on multiple chains interoperating with each other. This will be another huge leap, just like the generation of data has been a huge leap for the emergence of DeFi and the generation of random numbers and various off-chain computations in an Oracle network has been a huge improvement for NFTs and gaming. The ability to create cross-chain smart contracts will allow developers and people building smart contracts to utilize multiple different pieces of code on multiple different chains, just like they utilize multiple different pieces of code in multiple different clouds as web developers. They utilize the service and the piece of code that's the best suited piece of code for a task. That is how web applications are built. And what I feel the Chainlink network and the Chainlink ecosystem will be able to do by providing this cross-chain capability will be the emergence of smart contracts into a much more useful format. That format will be the cross-chain smart contract. It'll still be a hybrid smart contract because it'll utilize off-chain data. It'll utilize off-chain compute in Oracle networks, whether that's for randomness or keepers or whatever other computations. But you will actually have the ability to build smart contract applications the same way that web developers are able to build high-quality web applications. And at the most general level, that's what I think our industry and the Chainlink network and the Chainlink system and we as a community need to really do. We need to get the next 1 million developers coming into the blockchain industry to build the way they are used to building in the web industry. And the way they're used to building in the web industry is very quickly, at a very high quality, and with very cost-efficient and easily usable applications. That is what we need to provide as an industry, as an ecosystem, as a community. And while Oracle networks for data provide that for making DeFi applications, and Oracle networks for computation and random numbers can provide that for gaming and NFTs, the ability to stitch together multiple pieces of smart contract code on multiple different chains, I think, is going to redefine how people build applications in our industry. Because you'll be able to use the chain that you want to use for what it's good at. You'll be able to use certain main chains for the security guarantees. You'll be able to use other chains for certain speed or scalability guarantees. And you'll be able to use many other chains essentially as storefronts. You'll have multiple contracts on those chains for getting value from those blockchains users into what will essentially be one large smart contract composed of multiple on-chain contracts and multiple off-chain services, providing both bridging in the form of communication and the ability to get data and the ability to do trust minimized off-chain compute that was previously inaccessible but necessary. This is the large innovation of CCIP. It creates what we feel is a cross-chain smart contract stack that is going to have CCIP as a key protocol at the center of it, enabling communications. Then that protocol can be used on decentralized Oracle networks like Chainlink, and it can have key additional capabilities like the anti-fraud network to prove that the transactions going through it will be accurate and reliable. This will enable various key innovations like programmable token bridges, various cross-chain bridges built by people in the Chainlink community and the Chainlink ecosystem, and what we're calling cross-chain dApps and cross-chain smart contracts, all of which can still be used from the existing interfaces, the existing wallets, the existing systems, as well as various enterprises and other existing Web 2.0 systems. I believe that this will complete the three key categories of what the Chainlink network and decentralized Oracle networks do generally, going from the provision of validated data to off-chain compute to cross-chain communications, such that you will be able to send messages between contracts for them to use each other's services. You will be able to send tokens between contracts with minimal additional work, and this will give rise to cross-chain smart contracts that are enabled by highly validated data and bolstered by the ability to get random numbers and keepers computations and various other advanced computations like FSS in order to combat various other issues and provide clear cryptographic guarantees to users. This is where I think the Chainlink network is going. This is where I think decentralized Oracle networks provide a unique type of value to their developers and developers' users. And I think this together will herald in an entirely new category of more advanced hybrid smart contracts, just like we've seen the initial versions of this with highly validated data and some randomness and some computation start to make more and more advanced DeFi contracts. But really, that is just the beginning. And I see this expanding far beyond that, in the same way that the web world initially got some of its key services, but then there was an explosion in services. And that explosion in services was driven by, by the demand created by application. This leads us into a discussion about how all of this adoption fundamentally affects the Chainlink network and how all of this adoption fundamentally affects its economics. I personally feel that the continual growth in smart contract dApp usage and adoption will continue to generate hundreds and thousands of unique and highly useful and uniquely useful decentralized applications across multiple chains, multiple blockchains and layer 2s. I also see that our ability to provide data, compute, cross-chain communications, and any number of other key decentralized services. Once again, every key computation and piece of data that a blockchain cannot generate in and of itself. As we provide more and more of that, I think all of the fees from the smart contract dApp usage continues to grow because the user base of the dApps grows, and therefore, at the end of the day, the dApps fees grow. The amount of dApps and the fees paid by dApps for more services grows as they consume more services and as there are more applications to consume those services. This creates a very logical dynamic where the fees from the dApps flow into the node operators. In terms of this dynamic, I'm once again, for this year, as a milestone for this year, I'm very proud to say that we have multiple Chainlink Oracle networks that have now become profitable simply from the point of view of dApp fees. This is a unique and special milestone, in my opinion, because many, if not all, blockchain systems rely on something called a block reward. Many of them rely on it to over 98%, with user fees only making up 2%. Some of them rely on it anywhere from 60 to 70%, some of the more widely used systems. We have achieved certain distinct Oracle networks, certain committees of nodes that are able to run so efficiently thanks to OCR, have achieved efficiency because of the efficiency gains of the chains they're on, and have enough user demand happening quickly enough that they have become completely profitable. They don't require a block reward or an Oracle reward of any kind to operate. And this milestone has led us to plan for staking's release in this coming year. In addition to all the fees that are going to node operators, there is now a kind of, production possibilities frontier or a set of diminishing returns that node operators are starting to experience and I think will continue to experience. And what this means is that many of our node operators have done such an amazing job integrating the best technology and the best practices and the best methods for keeping their nodes live, that they are reaching levels of efficiency that at certain points have diminishing returns and at certain points can be approved upon only through certain means. Now, no other Oracle network that I know of has approached anywhere near this type of security. So at the end of the day, this is a great achievement, and this is why I think our nodes and our Oracle networks are so preferred. But wherever we are on the kind of security impact curve here, it is safe to say that as the amount of fees grows, which it is massively growing based on all the new dApps and based on all the larger adoption by smart contracts and based on all the adoption by basically the world, we're seeing what we call the current and future fee opportunity continue to grow. So the current future fee opportunity is the fees that node operators can get by being top node operators in certain categories of computation, whether that's data or whether that's computation, whether it's random number generation, whether it's cross-chain services. And in addition to being top node operators, I think the size of the committees is going to grow, and it is already growing. So we will not only have higher quality nodes, but we will have larger and larger committees for the more value securing transactions and categories of transactions. But if we reason about this from a purely economic point of view, and we ask ourselves, what is the most impactful but lowest costing security improvement? We start to go up the security impact curve, right? We implement secure signing. We get multiple data sources. We have node fallbacks. We have detailed monitoring and observability. We implement various signing schemes. And eventually, we kind of hit a certain level of diminishing returns, basically. At a certain point of diminishing returns, the additional security and reliability best practices that are implemented by nodes will become a minimum, because the fees will have grown to such a large point that not having that minimum, not having a certain secure signing capability, or having multiple data providers, or having certain fallbacks, the fees will justify that minimum of cost. And that will be the minimum that nodes need to meet. And many, many nodes will meet it, just like many nodes meet certain categories of security today. The question then becomes, what are the other categories that can allow nodes to gain greater and greater fees? How do nodes acquire a greater portion of the current and future fee opportunity made available by all these decentralized services used by this growing collection of dApps and growing collection of dApp users? And the fundamental answer that we have to that, as described in our Chainlink 2.0 white paper, is two dynamics. The first dynamic is node reputation and the value placed on that reputation. So node reputation is the history of low latency, accurate, and service agreement meeting performance that those nodes have achieved. So that means they've been up during congestion. That means they've delivered accurate data. That means they haven't had downtime in normal periods of operation. That means a number of key metrics which show that that node is the reliable node that is able to deliver highly reliable data through various adversarial periods and during daily operation, right? So the better that a node is at uptime, at resisting adversarial situations, at delivering accurate information, at doing accurate computations, that is a clear set of differentiating factors. An additional set of differentiating factors, and possibly one of the largest differentiating factors, will be the deposit. So the staking deposit that nodes are able to provide. And this is very similar to how blockchains work. You have certain chains where you have a staking pool, or you have individual stakers that provide a larger portion of stake, and they get a larger portion of transactions. And this is exactly the same principle. Those nodes and those staking pools have more at stake, and therefore they get to do more transactions. So in addition to meeting the security and reliability guarantees that, let's say, the top 50 or the top 100 or the top 200 nodes meet to get into those highly lucrative, highly future fee and current fee opportunity filled Oracle networks, you will need to provide a reputation, which will naturally happen if you perform well as a node operator. And you, in many cases, will be able to get greater amounts of fees as a node operator that stakes, or as a Oracle network that stakes, or as some kind of pool that stakes. So at the end of the day, you arrive at a very similar dynamic where the ability to create a larger deposit amount gives you the ability to get more of this fee opportunity, which actually contributes to you having a better reputation, because you're doing more transactions, you're proving more about yourself over time. So this is the way that the staking incentives will work for individual node operators, is that they will provide stake that will give security guarantees to various users. Those users will see those security guarantees and want to deal with those nodes or those categories of nodes as Oracle networks. And this will propel those networks and categories of nodes towards a greater fee opportunity. This is how, in the long term, we see staking working. Generally speaking, what this means that as the fee opportunity grows and as more decentralized services are provided, there is a greater amount of dApp fees flowing into the system. that is sent to the node operators as node revenue, and it is sent to stakers in order to basically make it so that stake is provided. And those stakers can be any number of groups. It can be the node operator themselves. It can be individual users that lend stake to the node operators. It can be pools that provide stake to the node operators. It can be various categories of groups. And then these staking groups will then receive the relevant staking rewards for providing that collateral and that deposit to provide those greater security guarantees in the same way that they're provided in the world's top staking blockchains. This is something that we are planning to release, or a version of this is planning to be released in this coming year. We do plan to see staking and staking rewards being made possible this coming year. And now that we have reached a certain level of profitability for some of the Oracle networks in the Chainlink set of networks, we feel that it's a good time to do this. This is obviously a very complex problem because just like Oracle networks generate a unique form of decentralized computation, different from blockchains, the staking that is applied to that unique form of decentralized computation also needs to be unique. And so we have been, feverishly working on different aspects of staking and how to make sure that both the security benefits and all of the proper incentives are in place to generate the maximum degree of security. On an Oracle network level, it actually works in a very similar way. So you can go up the security impact curve. As you go up, you achieve naturally diminishing returns. Marginal utility of each additional security impact could decrease, but the cost might increase. The future fee opportunity justifies that because it continues to grow. And then you eventually arrive at a kind of plateau for traditional security best practices. And here you can once again differentiate yourself as a network by being composed of nodes with the highest quality reputations and data providers with the highest quality reputation scores. And you can provide a sense of collective staking or a sense of collective deposit guarantees from your network and for your network in some form, either through a pool or through some other category of mechanisms. And this greater staking guarantee provides the security guarantees that users will need to say that network, even though it has great security best practices, even though it has great decentralization and high reputation scores, is the superior network. It has more stake, it has more reliability, it has more skin in the game, it has more of a deposit, it has more incentives. And at the end of the day, that incentive, just like it incentivizes proper operation in various proof of stake blockchains, incentivizes proper operation in the Chainlink network. And likewise, the people providing the stake and the people providing the computation are uniquely incentivized to do that in their own unique way. All of this, once again, will move that distinct Oracle network closer to capturing more of the current and future fee opportunity, which is what they want to do and what they need to do in order to continue to kind of get more revenue from the network, right? So the massive gain of not only best practices, not only good reputation, but having a larger amount of stake than others will result in the same dynamics that you see in larger proof of stake networks, where a greater portion of fees is sent to those mechanisms at a certain ratio that determines the additional security provided by that stake. At the end of the day, I think these dynamics depend on adoption. They depend on fees, they depend on the amount of dApps, they depend on the amount of users of those dApps, they depend on the adoption of hybrid smart contracts, and they depend on the adoption of trust minimized applications as a unique selling point to users. Beyond that, I think there are a number of macro dynamics that determine the size of the hybrid smart contract market and the trust minimized application market. The hybrid smart contract market right now, if viewed as a percentage of the cryptocurrency industry, is still below 20%. That is unbelievably small, based on the superior transparency, user control, and returns that DeFi applications provide. This means that if we are able to achieve profitability for some of the Oracle networks providing data to DeFi protocols today, because OCR was launched and reduced cost by 10x, because chains are becoming more efficient, and because the user base is growing and paying greater fees in aggregate through multiple users, or as individual projects by using more services. I personally believe that DeFi can easily capture anywhere from a quarter to over half of all cryptocurrency value, because it is the superior way to utilize cryptocurrency as a yield generating mechanism and has any number of other properties in terms of transparency, user control, risk management. So the market size just for hybrid smart contracts is still in its infancy. And we have Oracle networks that operate so efficiently that they've already been able to achieve profitability in a market of this size with a total addressable market of over 2 trillion. So at the end of the day, I think the size of our primary user base, which is hybrid smart contracts, is set to become much, much larger over time. This is nothing to speak of when compared to the larger trust minimized application market and all of the value that will eventually migrate into smart contracts and hybrid smart contracts. So if we look at the hybrid smart contract market, the amount of value that can flow into it from derivatives, equities, gold, and various other categories is multiples of what it is now, even at small percentage points of those markets. Not to mention that many of those markets are now moving towards becoming more trust minimized by consuming decentralized services to prove things about themselves to their users. Eventually, this is the world we arrive at. We arrive at a world where trust minimized applications are not enough. This world may take a number of years. I don't know exactly how many years because I am extremely excited about blockchains and smart contracts, and every single year is the year that they're going to go big, and I'm always excited about them endlessly. But this is definitely, in my opinion, where things are going over a multi-year trajectory. This is over $1 quadrillion in value, and it is basically all of the world's value if you include everything else that's not on here. If you include ad networks, if you include global trade, supply chain data, everything that needs to be trust minimized. Because the fundamental question is, if you could provide people or enterprises or web applications or web application users the same exact agreement, the same exact interface, the same exact cost, the same exact speed, and a trust minimization guarantee, a reliability guarantee that means the contract will operate as expected, why would they ever choose something that doesn't provide that but does everything else? You have a fundamentally superior property that web systems can never acquire, but Web3 systems can acquire all the properties of Web2 systems. They can acquire all the speed, they can acquire all the usability, they can acquire everything. In fact, many of the existing Web2 interfaces are going to be how the Web3 systems are utilized. So at the end of the day, the fundamental question is not why would this happen, it's why would anybody in any of these industries choose a less reliable contract, all things being equal? And the answer is they wouldn't, because as rational economic actors, everybody would like the more reliable contract. This leads me to the third and final thing that I think Chainlink and the Chainlink network will become over time. Initially, the Chainlink network began as a set of decentralized services that are provided to the world's top smart contracts in categories like DeFi, NFTs, blockchain gaming, decentralized insurance, and many others that the Chainlink network and its many different decentralized services and network helped jumpstart. That, in my opinion, actually helped jumpstart the blockchain and smart contract industry into what it's going on to be today. The second thing that the Chainlink network is now becoming, in addition to the decentralized services, is a single interface through which all enterprises and Web2 firms can efficiently utilize all blockchain systems and all smart contracts on all blockchains and layer 2s, even including central bank digital currencies, assuming that they go on a blockchain. And to do that in an efficient, reliable way that allows them to scalably utilize all the blockchains from all their counterparties all at the same time. That is what I believe is coming in this coming year, in the following years, as enterprises and Web2 firms need an efficient way to interface with blockchains. The third and most important thing that I feel the Chainlink network is generating is a truth machine. The truth machine is actually what I feel most excited about and what I think will create the largest impact on society and many different societies globally, and actually how those societies interact with each other. Because there is a deep-seated problem when we as a society or as a set of global societies cannot agree on what the truth is. And in many cases, that is not possible in agreements that fail. In many other cases, it's not possible between institutions. And I sometimes feel that it's not even possible at a societal level. And that is a very serious problem. That's a problem that's worth solving. It's a problem worth working on. And it's a body of work that I am personally very excited to be a part of. And I'm very grateful to be working on with the amazing people in the blockchain industry and the amazing people in the Chainlink community and ecosystem. And I feel that we all have an important role to play in how we, as a large group of developers and academics and security researchers and node operators and data providers and even average community members, can once again impact the world in this critical way, where we take the world from something powered by paper guarantees and no shared truth to a world powered by cryptographic guarantees and definitive truth. That is the body of work that all of this is about. I think that Chainlink Network and we as a community and we as an ecosystem have an important role to play in that. And I'm extremely proud of the immense work that we've been able to do as a large group of people working together during this past year. The amount of value that the Chainlink Network has secured, the amount of networks that have been launched in a scalable way, the reliability and security guarantees that we've provided, and not only the breadth of data, but the continually increasing quality of data and quality of computations from top partners, not only the highly validated data and extreme quality of computations that we've been able to provide, but also the reliability and security guarantees has really reached a previously unreachable point. And if we continue to reach these new heights in providing cryptographic truth, I think it'll continue to enable our industry to do more. And that's what I'm extremely excited about doing. If this is something that you're excited about, if you're excited about creating a truth machine, allowing the world's enterprises to engage in using cryptographic truth to provide their users the guarantees that they'll soon and already are demanding of them, or if creating the world's decentralized services to take smart contracts into a new age of usefulness is enough for you, please contact us. We are growing rapidly at Chainlink Labs. Chainlink Labs has a unique approach to working together that I think has been working very well over time. I think it's amazing how we've been able to help build a great open source software in the form of the core Chainlink software and some of the other additional protocols around Chainlink. At Chainlink Labs, there is something called an idea meritocracy, where we make systems and processes to make sure that the best ideas win, and that the newest person or the person who's been working here, or the most junior person, or the most senior person, all allow their great ideas to be heard and acted on. And working with Chainlink Labs is a completely remote working experience that we've been doing from the very beginning. So we know how to do remote correctly. And we have a very high trust, high autonomy, remote working dynamic where people who know how to do remote work are able to do it in the right way. And people that don't know how to do remote work can learn how to do it in a really efficient, correct way. So you're welcome to join us at Chainlink Labs if you find this exciting and interesting. And beyond that, I want to thank everybody who's been working with us in all the different ecosystem companies in the Chainlink ecosystem, all the different node operators, data providers, and all the different community participants that have supported us in this past year and in the past years and are going to be working with us in the coming year. Thank you.